All right, so in this lesson, I'm going to be teaching you about calipers, the different styles of caliper. We have dial caliper, digital caliper, and a vernier caliper, as well as the different measurement functions that each one has to offer. So there's 4 different measurement functions that a standard caliper can do. This makes them extremely versatile and a go-to gauge for almost any inspection situation. Depending on your application, it might be the most common tool that you're using because it's pretty versatile, offers decent accuracy, although not as much accuracy as a micrometer. But so let's just get started into the overview. So as mentioned, 3 different styles: vernier, digital, and dial. They all read differently. A vernier scale is going to be using this linear scale. You're going to be looking for where the vernier scale lines up, and you're going to have to add these numbers together in order to get your final reading. A dial indicator makes that a little easier. It gives you this nice big dial for you to read. So you're going to be able to see partly where you are, close to where you are in your measurement, and you'll be able to use the dial to figure out your last part of it. So it's very easy to read. And then digital, very, very easy to use. Gives you direct reading. You can zero them and get them to zero at a certain spot where you want to take your measurement off of. Either way, whatever caliper you're using, we're gonna talk about best practices for each one. So when we're talking about the caliper, let's go over the components of them so that we can be on the same page when you're talking to somebody. So first of all, when we talk about the jaws, we have a moving jaw and we have a fixed jaw. So this jaw here is my fixed jaw. It's not the one that slides around with the moving bar. So we have a fixed jaw, we have a moving jaw. You can take your reading right here. If you have a caliper that has some sort of pressure wheel, when you're using a caliper, you can apply pressure here with your thumb as you're closing on an object. So that little pressure, either there might be a wheel or it might be just a little nub like this one here. This dial actually has a wheel. So as I am applying pressure, rotating that dial, you can see that it's using this wheel can be very helpful for getting the same amount of pressure as I move across to each measurement. So hopefully your caliper has one. It's very handy. If you don't have one, you don't necessarily need it. This digital caliper here doesn't have one, but still useful. They should all have some sort of lock at the top. So we got a lock right here. When you engage that, can't move the sliding jaw anymore. Disengage that, you'll be able to move it. And then when we talk about the different jaws, so we have the outside jaws here for taking measurements on the outside of something. And we have the inside jaws right here for taking measurements on the inside of something. So taking a measurement on the inside of that hole right here. We have a depth jaw. So on the back here, you have flat parallel surfaces on the fixed jaw and the moving jaw. So you can actually take a reading. Let's see, try to angle this correctly. You can take a reading and measure from the surface plate here to where this moving jaw stops when it reaches the part. So this is a great stable way to get a measurement if you have a surface plate. You're going to need a flat reference. You can't just use this wood table here or a piece of paper underneath or anything. It's got to be a flat reference surface like a granite rock. This is a great way to do it. Another way to do it is to use your sliding bar on the back here. So this again, this very small point at the end gives you another distance. So see on the camera, I'm gonna get a nice flat reading from the bottom of the caliper here to the bottom here, and that reads 1.001 in this instance. So 4 measurement methods, the dial and the vernier also offer the same measurement options. And take a look at your caliper. There may be different setups. Not every caliper is configured exactly the same. So how your moving jaws work, how they read on the scale. Just take a quick look, make sure you understand all that. When you're reading the caliper, as I mentioned before, you get a direct reading with the digital. There's really nothing more to explain, but I'll give you an example here. So when we're using the digital caliper, I want to just get a direct reading of a 1 inch right across the thickness of this part. If I'm going to use, let's compare all 3 for this step thickness here, 605. So I'm reading 605 with the digital caliper. I'm going to grab the dial caliper, and it's a little bit slow moving. Now with the dial caliper, set this down. You can see on this scale here, I've gone way past the 5, and I've actually gone a little bit past the 6. And how far past the 6 is going to be determined by the dial. So this dial is telling me it's about 606. Hope you can see that. I would say 606 and maybe a tenth or 2 higher. So that's how you read a dial. Again, it's pretty straightforward. It's almost a direct reading. Just need a little bit of math. With a vernier scale, we're gonna have to add the vernier reading. So once again, we take a look at this this caliper. Excuse me. So we know we're around 0.6 and a little bit more. So when we're reading this this caliper, the inch scale is on the top, and you can see where the 0 is. You're at around 0.6. And then as you try to find 0.6 what you add to it, you're going to look for whatever line here lines up perfectly with the scale here. It's not always easy. Sometimes it's going to be tricky because multiple lines will look the same. But this is how you read a vernier scale. And I do have another video that goes in much more depth on how to do this with better examples. So I advise you to check that out, where I really go into detail on how to read that. But for this video, we just want to focus on using the caliper and not necessarily reading it. So for the most part, I'm going to demonstrate everything with the digital today. So as again, there's an example with a dial. You get to the 1.3 mark. You can see that with your eyes. You're past 1.3. On the jaw here, and then you use the dial to get that last piece. In this example, it's 45 thousandths that you're adding to the last part of the measurement to get 1.345. When I did it, it was 0.6, and then I added, I think it was 0.6 again. So 0.606 in the example with this part. Okay, so as I mentioned, 4 measurement methods. Here's a kind of a quick summary of how you can use them. So I'm going to demonstrate all of these with this part here. You can find the drawings on the Pragmatic Metrology website if you like. But to do the outside measurement, we'll grab, across the width here with the outside jaws. To do an inside measurement, we'll grab across the inside of this diameter, 0.968. There we go, a little better reflection. You can do other features, 391, should be about 625. For the depth bar, you can drop it onto a feature and then bring it down, and you'll want to be careful to get everything lined up correctly. So when you're using the depth bar, you're going to want to kind of rock it back and forth on the part to make sure that you are getting a nice flat surface, flat contact. And when you're looking at your part, you're going to avoid any radiuses that might be on the inside. So if there are radiuses that your depth bar is sitting on, it's going to be a very bad reading for you. So a lot of features leave a radius when you manufacture them, or some sort of step. So you want to watch out for that when you're using a depth bar. And the same thing applies when you're using the depth jaw. So in this case, I just do it from the outside and I get a nice direct reading right here. Let's see if I can pull that out, 1.001. Now, if you're doing this from feature to feature, once again, you're going to want to make sure you're avoiding other radiuses. Maybe we could do it in this channel here, be better. Sorry, a little hard to demonstrate when I'm trying to see this on the camera, but there we go. So I got a nice flat surface, nice flat contact. Try to show you from this angle, right? You want to make sure everything's nice and parallel, nice and flat. And we're not on any sort of radius that might be in the corner here. I know this was made with an end mill, so it should leave a pretty small radius, but you never know. So you want to visually check for that. Forgot to mention, when you're using, the inside and the outside jaws, when you're using the outside jaws, go ahead and grab onto the part and kind of twist and shake and rock, and then you'll find a seating where everything fits nicely. So you'll want to make sure everything's engaged this way and this way. So want to get nice big flat surfaces, and you're going to want to be kind of close to the root of where the jaws come out. If you're out here on the tips, what a lot of people can do is they put too much pressure. You see it's 2.350. If I keep adding pressure, I can make that change by 1,000th. But if I do that when it's at the jaw, no matter how much pressure, found a spot where it's a little lower, it's probably the same spot. So 2.349, when I apply some pressure, when I come out here with the tips, let's see, 2.349. Well, I can't demonstrate this part is actually pretty flat. I don't think I can really demonstrate it, but the moral of the story, grab as much material as you can. When you're taking a measurement, don't just work with the tips, because you could really mess yourself up if you get a part where you can actually make these jaws flex. That would be very bad for your measurement. When you're using the inside jaws, it's a little bit more straightforward, but you need to kind of rock the part so that it seats as well. So don't be afraid to really get in there. If you start too low and you just rock and slide, and I'm pulling out with my thumb to get even pressure, and then it's going to lock in place. I can no longer jiggle it. And 0.968, probably going to go around. It's always a good idea with a round part to check a few places. Make sure that the part is round, that the feature is round. And when you're finished, wipe off your jaws. Make sure you didn't pick up any chips, any oil, and make sure they close back at 0. We're going to talk about calibrating in a little bit, but that's how you do all 4 functions. So we're gonna move on. Oops. Let's try this again. Hold on a sec. I apologize for there we go. Apologize for this little delay. So let's get caught up to where we were. Now, when we're talking about calibration, um, one of the first things you're going to do, verify the tool is clean, there's no chips. You're going to have to maybe wipe them off with your finger. Be very careful about that. These points can be sharp, but your finger will be a great way to grab onto oil and chips and wipe them off. Especially with the outside jaws, they can be much sharper. Um, and then when you're gonna check that everything's good when it's closed. So I've got 0 here. And one thing that you can do is hold it up to the light and see if you can see any light between the jaws. If you can, if you can visually see light coming through your jaws when it's closed, then the jaws are no longer aligned. And if they're not parallel, they're really not usable, because every place you take along the length of the jaw is going to give you a different reading. So if that's the case, I'm not going to show you because every caliper is different, and this caliper is actually in good condition. But if you need to, you might have to disassemble, loosen some screws, close this back up, and then tighten the screws again and do your check again. So it doesn't happen all that often if you keep this in good condition, if you never drop it, if you always handle it properly. But if you drop it, if you slam it around, if parts are on it, if it's oily, if chips get jammed in there, something like this could happen. So when you're ready, when you think everything's physically good with the jaws, go ahead, grab a Joe block, something that the size of, and we're going to go through and we're going to measure this Joe block. So I've got 0.999. That's this really should be reading 1 inch. So let me re-zero it, and we're going to go through and check everything. So here I've got 1 inch, pretty good, after I fix the 0. And I've got a ring gauge here. So I'm going to check the inside jaws. This is 0.99996. This is as close to 1 inch as we're going to get. The caliper is not going to be able to detect that level of accuracy. So we're going to aim for 1 inch with our inside jaws. And I'm going to sweep it around gently, kind of rock it, apply some pressure with my thumb. This is as close as I can get. So I would say maybe these outside jaws are 0.02 off. 1.5, hard to tell exactly with the level of accuracy. So that means any reading I take with the inside jaws is going to be off by about 0.02 potentially. I wouldn't recommend assuming that in all situations because it may be length dependent. We're going to talk about that in a little bit, but I would definitely maybe have these calibrated by an outside company, or maybe even replaced if I was doing a lot of inside measurements. We can do this again with the 1 inch block and the depth jaw, I should say. So I'm doing this backwards. Hopefully the camera's picking it up. I'm gonna hold it, and 0.999. So we're a little bit off from 1. Let me try that again, and make sure I'm nice and flat. I'm gonna lock it down. 0.999. So I've repeated. It's the same situation. Maybe if I'm doing a lot of measurements this way, I want to have this calibrated by an outside lab. We're going to do the last one. With the sliding bar, the depth bar. And it's a little trickier. I'm trying to make sure I get parallel contact. And I get 1.001. Again, this tends to be the least accurate way to measure anything with a caliper, so it's not unusual to see a problem here. It's very flimsy, it wobbles, and making sure you're nice and flat is difficult. So, But again, maybe you need an outside calibration lab to verify this. All right. So this is just going to let you do a quick check, make sure everything is still in good condition. This is not really the official way to calibrate a caliper, as we're going to talk about in another video. You need traceability and you need a good method. And this is more of a sanity check to make sure that you've got a good piece of equipment, but an outside lab is probably going to be your best bet. They're not too expensive to calibrate. It's usually worth the money for how much you used to get out of these. One last thing I mentioned, checking it at 0, doing some checks there, but you also want to do a mid-range check. So I did a 1-inch block on the inside and the outside, but you should also double check periodically throughout. I've got 3-inch block and I've got 2.999. If I grab a 4-inch block, let's see what I got here. 4-inch, I've got 4-inch. So it's not unusual for a caliper to be more accurate in one spot than another. The more you use these calipers, they can wear. You start measuring the same feature in the same size all the time, they can wear in that area. Or they can just get more error the larger you travel. So it's a good idea to check intermediate stages, which is what calibration labs will do for you. So here's a quick summary of what I did to check that the 4 functions are all in good condition. And you can see in the inside jaws, I got 0.999 on this ring. So I could say, yeah, the 0.999 is maybe 1 thou off from what the ring is known to be. So you're going to want to use a calibrated ring, obviously, and you're going to need to use calibrated Joe blocks or gauge blocks. That doesn't change. You're always going to need traceability, but you actually want to know that these things that you're calibrating with are the right size. And you can even do it with a larger ring gauge. You can grab, this is a, what is this? This is a 72.037 millimeter ring. So I'm going to switch this to millimeters. I'm going to try to switch this to millimeters. Hold on. There we go. Millimeters, reading 0. Flip on the other camera. So I'm reading 0 millimeters, and I should be reading 72.037 right there. When I open this up, let's take a look. So I'm at 72.00. So I'm about 0.04, 0.03 off. Which correlates with what we got when it was in inch mode. So maybe if you have some other size rings, you double check that your caliper's in a good condition. And I'm going to switch this back to inch mode. Come on. It's very hard to push these buttons sometimes. They're recessed, so you can't do it on accident. There we go, back to inch mode. So yeah, that's exactly what you need to do when you're ever gonna check calibration. You don't need to do this every time you use the caliper. I would definitely check the 0, when you close it. Make sure that it's reading 0. Before you do anything super precise that you need to use a caliper for and you have no other choice. But otherwise, this type of thing might be periodically, maybe once a month, maybe once a year, all depends on a lot of different factors, how much you use it, what your company policy is. So I already mentioned, calibration. I definitely recommend you do this with an outside calibration lab so that you get traceability, which is something you're going to need if you're working in an ISO 9001 environment, or pretty much any quality management system is going to recommend that. And try to remember if this thing is not reading zero um, because of some difference. In this case, I'm reading 3000s because I barely closed it correctly. Um, just pressing zero is not the same as calibration. That is somewhat correcting one potential problem, but it's not fixing the problem entirely. So when you have these digitals, just pressing zero is not going to cut it for calibration. And my own personal recommendation: these 6-inch calipers are relatively inexpensive. You'll get a good one for $100, and for a lot of places, this might last you several years, and then it wears away and gets looser. Gets coolant and chips, and it's no longer holding its accuracy as well as it used to. And I just recommend maybe you replace it. I know some people will keep their calipers in great condition for a long time, and that's great too. But there's no point fighting if this is worn away. If it's having trouble with its accuracy, don't be afraid to just replace it, and guarantee your peace of mind that it's holding its accuracy. So I mentioned accuracy a few times. So you might be asking, well, how accurate are calipers? Like I mentioned at the very beginning, they're the most useful tool. They have the most functions, but pretty much of anything else we're going to cover, they have the worst accuracy. So what does that mean? So for a 6-inch caliper like this digital one, or this vernier, or this dial. Oh, this is an 8-inch dial. But this 0 to 6 digital is going to have bidirectional accuracy of 1000. So what that means is anytime you take a reading, in this case, I'm reading 1 inch exactly, 1.000, could be plus or minus 1000th and still be within the accuracy of the gauge. So that gauge, as useful as it is, one of the drawbacks that gives it that versatility is it's not quite as accurate as other gauges. So on a 6-inch scale, 6-inch size, it's going to be about plus or minus 1000th. And as these calipers get much bigger, they can go 12 inches, 24 inches. I've used some that are 40 inches and even larger than that. The accuracy gets worse. So I only put the up to 12-inch range because that's what's pretty much most common. But double check with the manufacturer what the accuracy is, because this micrometer, this caliper, this 6-inch caliper is going to be more accurate than a 40-inch caliper. You can't assume same accuracy as you get bigger. So I would say if you're not sure, use 0.002 plus or minus. If you're not sure about your caliper, that'll be a good safe number to use when you're taking a measurement. And the next question is usually, well, when can we use a caliper and when can't we? And that comes down to the 10-to-1 rule of thumb, or the uncertainty of the gauge and the measurement tolerance. The feature tolerance. But for what I'm recommending, I would say you at least need a 10,000th tolerance zone. And if your tolerance zone is smaller than 10 thousandths, you're probably going to have to use something else. So a caliper is just not going to be accurate enough to give you confidence in your measurement. So I have a graphic here on the bottom to kind of illustrate this. If you look at the bottom line that goes from red to orange to yellow to green, back to orange to red, each one of those boxes represents 1,000th of an inch. And that blue dot represents where your measurement lands. And if you have a plus or minus 2 thousandths, then that dot could be shifted to the right or to the left 2 thousandths. And when you're doing when you're comparing it to a tolerance zone, if it falls into that tolerance zone, you have to double check that it's not too close to the edge. So if you are 1,000th away from your edge and you have a plus or minus 2, accuracy, that's certainly possible. You're going to be out of tolerance, and your caliper won't tell you. It's one of the downsides of using caliper, but it's true for most gauges. It's just worse because calipers usually have the larger accuracy. So if you're there in the green zone on the bottom, you go right, you go left, you're fine. You're still going to be in the tolerance zone. But after you move closer to those edges, you get closer to those warning signs. You may need to switch gauges if you're getting really close to your tolerance zone. Depending on your company policy and how critical the part is, you may want to bust out a micrometer or a CMM or height gauge, something else that's more accurate to verify. So, yeah, let's talk about some rules of thumb. First of all, you should be using calipers to check a stable process because if you're checking something that's unstable and you're using a gauge that has, a large accuracy, a large possible error, you may not be catching everything in tolerance. You're going to be on the edge of your tolerance a lot, which may go out. So I would say a caliper is a great thing to use when your odds of failure are low, you have high confidence in the manufacturing process and the part. You can do nice repeatable checks. It's not difficult to hold. It's not very unstable. You get nice registration with your jaws and you feel very confident using it. If that's not the case, you may want to use a gauge that gives you more confidence, gives you a better setup, has a better accuracy. The next thing I recommend is, open tolerances, nothing that's precision. If we look at, an example print up here on the screen, anything that says, plus 5/10, minus 0, that's not a good check for a caliper. This would be a very tight tolerance that a caliper is not capable of. But these all here, these 3-digit decimal points, measurements, according to the title block, they're all plus or minus 5 thousandths, which means you have a 10 thousandths tolerance zone when you're using 3 digits on this drawing. And these would be great features to use the caliper for. They're clearance features for a bolt, even though you don't necessarily know that. It's open tolerance. So nothing that's too precision, because this is not the most precision gauge that we have. And then my last one, I've seen some people use calipers for some really crazy and interesting measurements. But you just got to remember, no matter what you do, can you repeat? Can you take the caliper off and repeat the measurement and get the exact same reading? That's always important in measurement. And how many other features do you need? Do you need Joe blocks and 1, 2, 3 blocks and something else? And you got to do it from, underneath the part and around it. There may be a better way to do it. That may not be the most repeatable setup. So once you take down your fixture, can you redo it? If you can't repeat it, you can't trust the measurement. So when it comes to handling, I've kind of mentioned this before, but when you're using this thing, get a nice firm grip on it. You can't really hurt the caliper by obviously you don't want to drop it, so you want to have a nice firm grip here on the bar, on the fixed bar. Don't be afraid to grab it with both hands. Sometimes I'll register one jaw this way and I'll hold it with one hand, or sometimes if it's a really big part, I'll clamp it with both hands. Whatever you think gives you the most accuracy, gets you the best reading. Don't be afraid to experiment. As I mentioned, you can do things that if you try to do this with one hand, it may be a bit of a challenge. But if you bring in your second hand, spin it around, make it rock it on the rock there, get a nice firm reading, you can get a nice good measurement that way. So get comfortable holding it. It's not that delicate. Most of these are are pretty rigid and pretty stable machines. You don't want to throw them around, obviously, but you don't want to drop them either. So hold on to them as firmly as you can. As I said, make sure those jaws are engaged, not sitting crooked. So make sure you got nice firm registration and you're not at some weird angle. Let me do that on the. So yeah, make sure you get a nice grip, that you're not at some weird angle. You can see that where it's not getting a nice registration. I get in the habit of rocking and twisting and kind of jiggling everything into place, that it's hard for me not to do it after using this for so many years. When you're using when you're measuring a round feature, whether it's internal or external, I recommend you get a measurement on the outside, and then you rotate it around to get another measurement, because as you might be seeing, sometimes round parts are not actually all that round. So going around it multiple places, you want to go multiple places axially and around the diameter, just to make sure. With a small part like this, it's a little bit hard to show, but as parts get larger and larger, they'll get more and more out of round, and your caliper will be able to pick that up pretty easily. And when I'm using the caliper at all times, I don't know if you noticed already, but I'm always using my thumb to apply even pressure. I've developed this even pressure over time, and actually, periodically I compare it to a Joe block to see how much pressure. See, this might be too much pressure for this this caliper, because I know that it's just a little bit off when I put on my real pressure. So I need to maybe lighten my pressure when I'm using this caliper. But just develop a little even pressure for everything you're using. Make sure it's consistent, and double check with these Joe blocks when you need to. All right. And then last one, make sure your depth measurements are perpendicular. So I've seen a number of people, when they're measuring with the depth bar here, they'll be at an angle coming down, and this will not give you an accurate reading. You're going to have to make sure this is perpendicular, that these edges are flat. So yeah, kind of rock it around, twist it, apply a little bit of pressure, and then take your reading. It can be a little tricky sometimes. Depth measurements are some of the harder ones to do with a caliper. So make sure you practice those. Now we're getting close to the end. Just want to talk about some GD&T. Calipers are not the most accurate tool, but they are capable of some GD&T measurements. So if your tolerance is wide open on these GD&T, you can measure circularity. Circularity, you're just going to grab a diameter and you're going to spin it around and see how much the diameter changes as you go around. Position, you can do that by grabbing, from the edge of a hole, bottom of a plane, whatever your datum is. So you certainly can. You just need open tolerances, wide open. So hopefully your print has that way if you're going to be using a caliper. If you don't, you might have to use a height gauge for position or a CMM. Parallelism, pretty much the same thing. You're going to go across from your datum to your other plane, and you're going to do that in multiple places. So I'll do that here, and I'll do that over here, and I'll just keep moving it from left to right and get all my readings. And whatever difference I get, maybe I get a 3/1000th variation from the lowest to the highest, and that is my parallelism error. So those are the three that you can do if your tolerances are open. You can also do runout in some situations. I don't really have a part here to demonstrate runout, but if if this ring gauge was an actual part, oh, you know what? Nah, I don't have it. You can go from the outside to the inside, and you're going to grab, and whatever difference as you rotate this thing around, whatever your difference is, you're comparing this outside surface to the inside surface. That is basically a definition of runout. You can do it that way with a caliper. And symmetry, sometimes if you need something to be symmetric, you can just use your caliper to measure something is evenly spaced. So if you have a slot right there in the middle of your part, you can grab from one edge to the slot, the other edge to the other side slot. And if the slot is supposed to be right dead set in the center, then your two, let me draw this out. Your two measurements should be the same. So if you had a slot on flange, all right, and you need this slot to be dead center from some datum. Maybe we'll call this datum A. And if this is not proper GD&T call out, please don't come after me. I'm just trying to demonstrate a principle here. If this distance with your caliper is the same as this distance with your caliper, then you know the slot is centered relative to the outside, which actually, yeah, it should probably be datum A this way. So there you go. If you do it that way, you can use your caliper to grab this side of the part, this side of the part. If they're the same, then the slot is centered. If they're not the same, the slot's not centered, and there could be, you have to start a little investigation about which side is smaller, then which side is bigger, which side is right, which side is wrong. But you can do that if you need to. All right. Oh, I got this little problem again. I know how to fix it. All right, I'm going to jump ahead back to where we were. All right, so we're at our summary. So remember, I tried to demonstrate the 4 different measurement functions as many times as I reasonably could. You're going to get a large range out of this. I mean, how many micrometers have a 6-inch range? Some only have like a 0.2 range or even less. So this is what makes it so versatile. It's the range. I call it the Swiss Army knife of gauges because of how much the 4 different measurement functions and the large range. And I mean, it's pretty much true. You're going to be able to measure anything with a caliper. The question comes down to, should you measure everything with it, or when do you use another gauge? So I'll have more videos about those other gauges and when to use them. And in reality, I put on here inexpensive. This is for as much measurement capability as you get for it. It's pretty inexpensive. $100, $125 for a good 6-inch caliper is going to get you a lot of use. And I highly recommend you invest. If you're going to be a CNC machinist, an inspector long term, if the company's not going to get you a good one, this is one of those things where it'll be useful to you. You can be using it all the time. Not true in every case, but in many cases. But as I said, the last one there, just remember it's lower accuracy than anything else I'm going to talk about in this video series. So there are limits to its uses when you have some high tolerance features. So you're gonna have to decide if the tolerance is appropriate. And again, I recommend you use this this page here. Typical bidirectional accuracy 1,000th, so plus or minus 1,000th from everything you read with a 6-inch caliper. And you should verify that with your manufacturer. If you're not sure, you might want to err on the side of caution and say plus or minus 2,000ths from everything, especially going up to 12 inches. So that's it. I want to thank you guys for watching. After this video, I want you guys to check out the video on calipers where I'm going to demonstrate how to measure this part. We're going to go through a bunch of exercises using this part and step shaft part, and I'll show you how to do how to use the caliper to measure most of the features on this. Some of the critical techniques when you're using a caliper. So I recommend you check that video out, and please check out the website for more videos, more training. And I do want to thank Delaney College in the Peralta School District, where they provided some of these machine parts, the tools here. It's a great program in the Northern California Bay Area in Oakland. So if you're interested in manufacturing, CNC, manual machining, inspection, all kinds of things, welding, assembly, mechanical drives, they've got a lot of great courses there. So I recommend check that out if you're in the Bay Area watching these videos. And until next time, thank you.